Welcome to episode 145 of Paper Brief, where we dive into the latest in machine learning and technology. I'm Charlie, your host for today, and joining me is the brilliant Cleo, ready to unfold today's topic. So Cleo, we're looking at hierarchical spatio-temporal decoupling for text-to-video generation today, which sounds quite intriguing. Can you give us a breakdown of what this paper is about?
Absolutely, Charlie. Essentially, this paper introduces HiGen, a method based on diffusion models that aim to simplify the complex process of generating videos from text. It does this by breaking down the task into smaller, more manageable pieces, focusing on structural and content levels to create more accurate and stable videos.
Nice. Now, video generation has been a bit of a dark art. So how does this HiGen model differ from previous approaches in the field?
Great question. Prior models often treated the spatial and temporal dimensions together, resulting in a significant challenge and sometimes poor results. HiGen, on the other hand, decouples these dimensions, handling them separately in what they've termed spatial reasoning and temporal reasoning. It's all about simplifying processes to improve the final output.
Interesting. Spatial reasoning, temporal reasoning, sounds like they've really dissected the whole process. But could you expand on what these terms actually mean in this context?
Sure thing. Spatial reasoning is about creating a coherent spatial structure of the scene, essentially establishing where things are or should be. Temporal reasoning is then the process of generating movement within that structured space, essentially making sure things flow in a realistic manner over time.
And they've managed to do this for any given text input. That's pretty impressive.
Yes, and that's what's especially exciting. They use text prompts to guide the spatial priors and then build temporal movements on top of that, leading to some convincing and stable video outputs. Moreover, they've added another layer to this by separating cues within the content that account for motion and appearance changes. These cues can alter the generated video's look and motion, giving creators an extra layer of control over the end product.
Control over the end product is crucial, isn't it? Are there any examples in the paper that illustrate these concepts well?
Yes, the paper mentions several interesting prompts used to test the model. For instance, one of the prompts describes an astronaut riding a horse, and their system is able to generate a video that accurately reflects that scenario, with both motion and appearance factors appropriately adjusted.
To wrap things up, Cleo, how do the results from HiGen compare with other state-of-the-art methods in text-to-video generation?
The results are quite promising. HiGen has outperformed existing models in terms of the accuracy and stability of the generated videos. Plus, the paper details extensive experiments that showcase superior results on a public dataset, which is very reassuring for its future applications.
That's truly fascinating. Thanks for sharing your insights, Cleo. And thanks to our listeners for tuning in to today's deep dive on HiGen. Can't wait to see what people will create with this technology. Until next time, keep exploring.
Thanks, Charlie, and thank you everyone for listening. Keep an eye out for HiGen and the exciting advancements it brings to video generation. Take care.